In today's video, we're going to take this interesting retail point of sale keyboard and see if we can do something maybe slightly useful with it. So this keyboard I bought for spares when I was making my fake dumb terminal, the Franken terminal. And mainly I bought it because I needed spare keycaps. But there's an interesting device here, and I think it might have some potential. I don't even know if this works, so we've got to test that and then see if we can actually make something out of it. So a bit of a kind of laid back experimental video. I'm going to sit here with a cup of coffee, take this thing apart and see if I can figure out how it works. Let's talk about the keyboard itself for a moment. This is a Ortholinear membrane retail keyboard. It's intended to be for a cash register. It's got some interesting features. Firstly, it's this grid layout, which is not by any means new. You might have seen mechanical Ortholinear keyboards. This is a membrane Ortholinear keyboard. I think this is probably about 20 to 25 years old. So not a new idea. It's got these interesting keys. So let's have a look at the keys. This is one that's got a re-legendable keycap. So the little transparent keycap comes off. And they have this post underneath that slots into one of these holes. And you can literally just snap the key in, and that's a functioning key there. And if you don't like where that is, you can pop it out and put it somewhere else. So all of these keys here can be rearranged. If I want my P key up there, I can rearrange it and then reprogram the keyboard so that that key is now P instead of that one. It also has double keys and quadruple keys. And these are interesting in how they work because they've got a built-in stabilizer built into the actual key itself. Again, the keycaps come off. So all of these have removable keycaps. But the interesting thing with these is they span two keyholes, but obviously only activate one key. So, and actually that stabilizer works surprisingly well in there. I think it's probably natural to be doubting that this little plastic stabilizer here has any meaningful effect. So there's a key with the stabilizer on. And here's one where I've removed the stabilizer. Oh boy. Well, there we go. Very little doubt in my mind that that stabilizer makes a difference. And the same thing with the four-way key. It's the size of 4 keys, but it only activates one key. And actually, you can put the keycap on any way round you like. So let's just pop that off and I'll show you. The quadruple keycaps don't come off quite so easily. But yeah, that key can go into the keyboard any way round you like. And it makes very little difference. And then that keycap can go just on top. And again, not bad. And again, not bad. They are a little bit rattly. They are a little bit scratchy. You probably can't hear that. But actually altogether, they don't stick, they don't jam at all, which you might think they would, especially these double-sided keys. These are rattly, that's the stabilizer. That's possibly a bit annoying. But it's not a bad keyboard for a membrane keyboard. I mean, I know mechanical keyboard nerds are going to recoil in horror from this, but objectively, it's not a bad keyboard. So what can we do with it? Well, we could make the world's largest macro pad out of it, but I think first we've got to get it going. It's got a, oh, I forgot to mention, it's got a card swipe slot on the top here, which obviously is no use to me. Hopefully we'll be able to get rid of that. What I want to do is try and build this into a different case, perhaps. There are a number of challenges to overcome. Firstly, I don't have the cable for this, and it's got 2 ports on the bottom, one of which is a PS2 port, so it's like a old-fashioned keyboard or mouse port, and the other one here that's marked PC is very similar to a PS2 port, but it's got 2 extra pins. The keyboard's made in Germany by PrehKeyTec, which is a specialist in this market sector. I think now it's time to take it apart and see what's inside. There are no screws, not even under these little rubber feet. There are just 4 little clippy tabs here. So I'm assuming the whole of this top case comes off when we just undo those tabs. So let's have a go at that. This is going to be one of these things, isn't it, where you undo one and it comes apart a bit, and then when you clip the next one, oh no, it's not too bad. It's not too bad. I spoke too soon. clip together plastic tabs sometimes are really annoying because sometimes you get one undone and then you go for the next one and the first one clicks back shut again. Okay, it seems like the only bit that comes off is that. So that just that bit of cowling there. The card reader thing appears to be a separate module. That's good news. That's the little module that has the num lock and caps lock lights. And then the keyboard itself, oh, is a okay. The keyboard itself is a separate board with a very heavy metal base. Galvanized steel base, about 2mm thick by the look of it. So quite hefty, quite strong construction. And then this will be the controller board here. So let's try unplugging a few things. And let's get rid of that card module for a start. Don't need that. I'm not even going to bother trying to test that. And then we've got the keyboard ribbon cable. I think we will just pop that out. It's not one of these low insertion force jobs, but we don't need that connected right at the moment. And then the little light module, I think we'll just pop off of these plastic lugs here. There we go. So we've got two components. We've got the board itself, which is very nice and solidly made. I think we'll find when we put that on a solid surface. Oh, we can't because of that earthing clip there. Let's take that grounding. There's a little grounding clip there that communicates the ground plane from the board to these sockets or vice versa. So presumably that's just part of the ground plane for the device. I'm going to take that out so that I can lay this board flat on the desk. When we have this flat on the desk, it's a bit mushy sounding. I'm not really that hung up on how the keyboard sounds. I don't know why I'm focusing on it so much. Anyway, that's the keyboard. And then we've got this little controller board here, which again appears to be just held in with a plastic clip there. So let's get this board out of the thing. Again, just one little plastic clip there. So just give that a twist. And this board should lift out. Yeah. Okay. Right, so we can get rid of the plastics and focus on the board. So it's got these, that's the PS2 port for another keyboard. Now the reason it has these two is you can plug a keyboard or mouse into it and it kind of piggybacks through, it kind of passes through. So I think this is intended for when you're debugging one of these devices. You can just plug a standard keyboard in there and then you'd get all of your standard keys rather than whatever the retail thing is configured to do. Probably intended for engineers. But there's this other one which resembles a PS2 port but has two extra pins where the little keyway would normally be. If we look at the pin out for a PS2 plug and socket, it's like this. Only 4 of the 6 pins are used, which is 1, 3, 5, 4 and 5. So 1 is data, 3 is ground, 4 is 5 volts, and 5 is clock. So a PS2 keyboard is essentially a serial device. Now, if I was designing this myself, there's no guarantee that they have done this, but if I was designing this myself, I probably would have kept the plugs the same as the PS2 standard, just to keep things simple. So I think probably what we've got here is, let's just have a look. So we've got 1, 2, 3, 4, 5, 6, and then we've got 2 in the middle. And I imagine probably these 2 in the middle are intended for triggering a cash drawer to open or something like that. Probably you can get a special cable that goes in here and it splits out and has a cash drawer trigger or something like that. I mean, either that or they made this a proprietary cable so that you have to buy the right cable, or maybe they made it a proprietary cable so that you couldn't plug directly from there into there and create a loop. I don't know. Anyway, what we've got to do is figure out what this port's doing. If this is the same standard as PS2, then that pin there should be ground. So I think what I need to do is jam a little bit of wire in there and then test if there's a ground connection. If that works, then we'll go on to the next stage. Right, paper clips to the rescue. I think what we'll do first is test my theory on the PS2 socket right there. So I'm just going to test the resistance of that casing, which presumably is grounded, to that pin. Yeah. So in the PS2 port natively, not got a great connection, but we can see that's grounded. Okay, let's see if the same is true of that corresponding socket in the custom thing. Bit of wire's a little bit too thick to go in there. I hope I'm not damaging the terminals. Okay, so moment of truth. Yes. So what we should find, let me just test that I'm not being completely stupid. I'll put it in the pin opposite, which should be the 5 volts connection. And we shouldn't find that this shorts out. It does. Not good. Okay. Might need to reconsider this then. I wonder if my pins have gone all the way through and touching the back case or something. Okay, might need to do something else for reverse engineering this. For example, I might need to actually just try and probe these pins and trace them and see where they go to, and then identify the chip and so on. This could get more complicated than I thought it was going to be, and I may give up. What I have got is a very low resistance between the definitely 5 volt pin of the PS2 socket and the theoretically 5 volt pin of the incoming keyboard socket. Finding it very difficult. I should get some little clamp probes, but I haven't got those. Well, I think the next thing to do is to apply 5 volts to this and ground to this and see if anything happens. See if we get, I don't think there's a sounder on this board. I don't think there is a little sounder, but there's some lights, so we might get some activity. So I'm going to apply 5 volts across those 2 pins and we'll see what happens. For this we can use my USB battery stick. So that's actually powered at the moment. Let's just test we have got 5 volts. Something like 5 volts. And I'm just going to do a makeshift connection there for ground. So here goes. Did something just happen there? I don't think it did. No, nothing. So that might indicate any number of things. It most likely indicates that the thing's busted anyway, because I did buy it for spares and repair, so it might have failed already. It might indicate just that none of those lights should be lighting up. Alternatively, it may indicate that my guesses about the pins are incorrect. Just going to try it. This could make the magic smoke come out now. Just going to try it the other way around, because they might have actually mirrored the connections. No, nada. That's annoying. Yeah, I think what I might do here, I should better push 5 volts back into here, and we'll see if that makes any difference. I mean, I could just wire up a connector. I could go and buy the right cable, but it's like £20 to buy the cable and then another £20 to have it shipped to me. I'm not paying £40 or whatever just for a cable for something that may not work. So, socket, it's definitely that way around. Ah, now we got some power, we got some lights on there. That's interesting. So that does indicate that the thing works, but it also indicates that my guesses about these pins are incorrect, which is annoying, because that means I can't reverse engineer easily this connection. Okay, so through trial and error, I have discovered, in fact what I did is I put some wires in here and probed between these 2 sockets so I could figure out which was power and which was ground by measuring for 0 resistance between respective pins. So in this 8-pin socket, or the equivalent of pin 3 here is actually VCC, and the equivalent of pin 4 is actually ground. So it's kind of almost like they reversed it, which I presume is just because it's looking the other way down the cable, because it's got one of these plugs on the other end. I don't know. Anyway, the progress we now have is, look at these little lights, Now if I apply power across there, we've got lights lighting up. That's not doing anything obviously, but that to me indicates that we've got some life. So if that's 5 volts and that's ground, which is the same as the plug, I think it's reasonable to assume then that that's data and that's clock. Same as the plug essentially. So pins 1 and 5 are data and clock. Pins 3 and 4 are ground and VCC. So I think that's the pin out we've got for this. I guess the next thing to do is to get a PS2 cable, wire it up into these pins, and then see if we can actually get some life, see if it's recognized as a keyboard. Right, here's what we're going to do to test this. I've got a USB to PS2 adapter dongle thing here. I've got the pins wired from my 8-pin to the socket version of the PS2 there. I've got the keyboard plugged back into the ribbon cable. I'm going to plug this USB into an old laptop. There would be a risk from doing this directly to a PS2 port on a motherboard, but I believe this is the thing taking the risk now. So if this goes pop and the magic smoke comes out, not the end of the world. So there might be people yelling at the screen right now, why don't you just wire it up to a USB cable? And you can do that with some modern keyboards, because modern keyboards that have USB and PS2 as their connection options support both protocols. And they do that by detecting what kind of host they're attached to and then adapting and communicating on that protocol. You can't just interchange PS2 and USB if the keyboard doesn't support it. And this one almost certainly doesn't, because it's really old. And worst case, if the USB destroys the port in the laptop, which seems unlikely, then it's an old laptop that I use for experimentation like this anyway. So I guess I'm just going to plug it in and see if it actually lights up, because that'll be the test. Okay, we've got lights. These aren't the right keys. I've just put these keys on here for reference anyway, but I'm just going to open up Notepad on this computer and pound on these keys and see if I get anything. Okay, well, that's interesting. I've got a thing that says barcode reader is set up and ready to use. That means it's recognized the keyboard. That's a really hopeful sign. So, Notepad. Wow, this computer's so slow. To think I once did all of my computing on this machine. Okay, and well, something went beep there, something happened. It might well be that this keyboard is completely unconfigured. That's a bit of a disappointment. I was expecting that we would get at least some key presses here, but it might well be that the configuration on this keyboard has been wiped. So what I will need to do is load up the PrehKeyTec software and see if I can actually program this device when it's attached. Oh, I can't program it because it doesn't work through these things. It doesn't work through one of these USB dongles. That's a pain in the neck. Reason being, this is unidirectional. This is only expecting to receive inputs from the PS2 devices. The PrehKeyTec programmer needs to be able to push data out to the PS2 port, which is unconventional, but that's how it works. However, it might well be that we've got the data and the clock in the wrong place. I've got a feeling that beep might be the keyboard buffer filling up here, which means it's not able to communicate with the host. So a little bit more work to do, but we are getting somewhere. Okay, we are going to brute force it. So I've got the 4 pins of the PS2 adapter wired into here, power on that rail, data on these rows. I've got the 6 unassigned pins from this 8-pin DIN connector on these rows here, and all I've got to do is try every single combination in both directions, and we'll find the one that's the right for this keyboard. Those 2 are missing there because obviously those are the power pins on this thing. We don't need to test those. So I better plug this in, or else the whole test is pointless, and then off we go. Make sure we've got life in the thing first. So just plug that in. Yep, there we go. We've got lights confirming something's happening. I'll get Notepad up. Okay, and I'm going to unplug every time because PS2 keyboards don't like weird things done to them. Okay, so it's not those 2. I'm trying the 2 middle pins first, just in case they decided to be a bit contrary and use those for data and clock, so that you couldn't even use a PS2 cable if you trimmed off the key. No, doesn't look like it, so not those two. Okay, well I'm just going to go through these one at a time, starting with that pair, until I find the right combination, and hopefully I will find the right combination. There it is, yay! So it is on pins 2 and one of the middle pins. So by sheer brute force, I mean these are not the right keys, but it doesn't matter, we're getting something. So actually on that connector, clock is on pin, well if that's pin 2, and data is on this middle pin here. That is the pin out for that PrehKeyTec connector. There is just one more small but important detail to figure out before I go to the trouble of building a case for this, and that's, can I program it? Can I use the WinProgrammer program to program this board using my makeshift cable setup? So that's what I will test now. Yeah, definitely should have done that one first, would have been far less fiddly than that, but never mind, we'll get in there. Okay, so I've got those just manually jumpered into that socket there. I'm going to plug that into my PC now and then try to program this keyboard. I'll just try and program one key. Let's say the third key along on the top row is going to be P. I am a little bit worried about the number of times I'm having to plug and unplug this ribbon cable. I'm trying to be as careful and gentle as I can, but there is a risk here I will wear out these traces on this ribbon. And once that's done, there's no going back. Okay, that end goes in the PC, and then we'll get the software fired up and try to program that key. Okay, so we're all set up to go. By the way, is my Cherry compact keyboard that I'm testing. It's not going all that great. I had high hopes for this keyboard because it's a nice compact design and it gives me a little bit of extra desk space when I've got my macro keyboard on the left of it. But the build quality and the quality of the switches is not that great. I mean, look at it. It kind of flexes. That's not good. Anyway, that's by the by. We're going to try to program this using PrehKeyTec's WinProgrammer, which is a fascinating bit of software. It's obviously got some vintage to it. So select keyboard type. We are MC128WX is the keyboard we've got. And there we go. So we've got a grid layout of keys. And I want to program this key here. Change key label. I'm just going to put a P on there. And change key assignment. And we can do some interesting stuff here. But I am just going to assign it to P. Okay. I can't remember exactly how you do this. Update keyboard, there it is. We're connected via PS2. Well, now we have a problem. No, so it's not detecting that keyboard, which is a bit of a bother, really, because Windows is detecting that keyboard. RTFM. Turns out that in order to work this, in order to program this, the drivers that you need to push the data via a PS2 connection only work in 32-bit operating systems. They just don't work in 64-bit, and they're not planning to do an update to that because this is legacy technology. They're not going to write 64-bit drivers for keyboards they made obsolete years and years ago. So now I've got to dig out a machine that has a PS2 port and a 32-bit OS on it. I think I've got one. And here it is. Yes, it's the PC I was going to make into a piece of wall art. I've kind of blown some of the dust off of this. I've got a disk boot failure at the moment, so I've got to see if I can get this spun up with a 32-bit OS on it. So I reckon I'm going to install Windows 7 on this machine, and I think that calls for an installation montage. Here we go. Okay, everything is set up now. So Windows 7 running on this old PC. The keyboard's plugged into the control board. The control board is wired with jumpers into the end of that PS2 cable. The PS2 cable is plugged into the weird PC. Everything's ready. We should be able to run WinProgrammer now. Sorry I couldn't do screen capture on this machine. It's just something I couldn't actually be bothered to set up, to be perfectly frank. So we're going to select the keyboard, MC128WX. We might as well have a UK layout. And I'm going to program this key here as P. Just change the label. We don't really need to do that. It's just helps if you're working on this software. And then change key assignment to P. You've got all sorts of options here for different layers, for shift layer, control layer, and so on. But this is assigned to P. And then we're going to say update keyboard. Okay. Do not move your mouse during transmission or cancel. Okay. Oh. 330 bytes sent. Well, is it going to work? It works. Great. Okay. Oh, that was a bit of hard work, wasn't it? Okay, this video is getting quite long now, so I think what we'll do is just finish off with programming the main functions of this keyboard. So I will program the alpha area, the number row, the number pad, and the F keys, and a few other things like shift and alt and space and return. And we'll probably leave it there. In a future video, and hopefully not too long this time, I'm going to build a case for this keyboard to make it into a proper keyboard that can sit on a desk. And I think at the same time, I'm going to build a case for this PC. I'm going to finish this project here because this thing's proved its worth now. And also on the keyboard, I'm going to look at how we can print our own keycaps, because I've got lots of keycaps, but most of them say something irrelevant like customer details or cash or check. These are keycaps that have been printed for retail purposes, but they're no use to me. So I already know that I can sand off the existing printing more or less effectively. And so it's just a question of how do I print neatly my own keycap legends. So that'll be all for today after we've just programmed this keyboard and proved that it works as a keyboard. And I think that calls for a programming montage. Here we go. Okay, so that one that says retail sales is actually caps lock. I've got to re-legend that, but we can see the caps lock function is working. Okay, and away we go. Not comfortable, I'm going to say. Not because of the keys, but because of the layout. This ortholinear layout is just a bit weird to my fingers, and my muscle memory's not working. So I'm having to actually hunt and peck, essentially. But it works. I'll show you what we got on screen up there. That's what I've just typed. So it does work. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then shifted 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That seems to be working. Number pad 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Carriage return is working. Cursor keys are working. So it all works. And I think that's where we're going to end this video. In a future video, I am going to make a proper cabinet for this wall-mounted PC. I'm going to finish that project. I always intended to do that. And I think I'll make a case for this keyboard as well, so it functions as a proper desktop keyboard. Not sure I'm going to use that in earnest. That's not going to be my daily driver. But I might keep it as the keyboard for this machine because they are kind of birds of a feather, aren't they? So, a bit of a weird video. I hope that was interesting in some way. Thanks for watching, and I hope to see you again soon.